Alright guys, pretty quick we're going to finish up 2D projectiles. Something that is shot or thrown horizontally is called a 1D projectile, even though it's still a 2D motion problem. It's called a 1D projectile because it only has one dimension in its initial velocity. Things that are thrown or shot at an angle, whether it's up or down, are called 2D projectiles, but they're both cases of 2D motion. So real simple question for you guys. Let's say you have a rock and you go outside. Even though you're not allowed to go outside, you go outside and you want to throw it as far as possible. Wow, what a great physics experiment. I know, thanks. If you want to throw a rock as far as possible and assume, like yesterday, it lands at the same height it starts. So it starts, gets launched in the air, and lands at exactly the same height. What angle should you throw it to make it go the greatest horizontal displacement? You should throw it straight up. No. If you throw a rock straight up, it'll come back straight down and hit you on the head, on your soft baby head, and that'll be 0 horizontal displacement. So straight up 90 degrees is not the right answer. You should throw it at 0 degrees. Maximum horizontal displacement, you want maximum horizontal velocity. That's a very common misconception. No, Daisy, you don't throw it 0 degrees. Remember I said it starts and lands at the same height? If you throw it straight horizontal, in real life when you throw something, it starts at your arm height. But in this problem, if you throw it off the ground at 0 degrees, it'll hit the ground immediately and also go 0 meters horizontally. Maybe the rock would roll, but we're not talking about rolling, we're talking about going through the air, a projectile. So it's not 0 degrees, it's not 90 degrees. Is it somewhere in the middle? Oh, I don't know, maybe 45? Yeah, Hazel, that's right. Prove it. Prove it? No way, I can't do it. Fine, I'll do it. I'll prove it's 45, and I'll do it algebraically, without numbers. Which is a very, very common thing to see on the AP test. So watch me do it without numbers. So we want the maximum dx. We know ax is 0. We know ay is negative 9.8, a very common shortcut for negative 9.8, or 9.8, negative g. So g is 9.8 meters per second squared, negative g, we have negative 9.8 meters per second squared. And we know dy is 0 meters. So I'm going to solve this problem algebraically, and then we'll know the answer. Then we'll have proof that 45 degrees is the best angle. And hopefully it won't take too long because I want to do another problem too. So we're using dx equals vx naught t plus 1/2 ax t squared. 1/2 ax t squared is 0 because ax is 0. So this is the equation we're going to use to solve. But we don't know t. We're going to find t on the y side. Oh, I forgot. V theta. So when you're throwing a rock, you're always going to throw it as fast as you can. So your V is the fastest speed you can throw. The question is, what's the best theta, right? Yes, yeah, well I said so, so yeah. So we know we're throwing the rock at speed V at angle theta. Vx naught is obviously therefore dx equals v cosine theta. So dx is v cosine theta t. And what's vy naught? V sine theta t. No, v sine theta. Sorry. Okay. So we gotta find t. Same method as before. dy equals v. These are both knots. Sorry. It's fine. It's fine. Until the end of this video, it's fine. Okay, good. Since dy is 0, we can use the trick. Divide the whole thing by time. 0 over time is still 0. So 0 equals vy naught plus 1/2 ayt, not squared, just t. 0 equals v naught sine theta plus 1/2 negative g t. Is this off the whiteboard? Yeah, it is off the whiteboard. 1/2 negative g t. Solve this for t. T equals 2 v naught sine theta over g. The negative goes away because you add it to the left side. We are scholars, we did it. Plug this t right in there. dx equals, this is a v naught also, sorry everyone. V naught cosine theta times 2 v naught sine theta. So 2 v naught squared sine theta cosine theta over g. All right, now is big brain time. dx equals 2, no, v naught squared over g times 2 sine theta cosine theta. Another way to write this is sine theta cosine theta plus cosine theta sine theta. You probably don't need this step if you recognize this. It's a trig identity. 2 sine theta cosine theta is sine 2 theta. This is also the same identity. You might know it. What's the formula? Sine A plus B is sine A cosine B plus cosine A sine B. I'm not being paid to be a math teacher, so I'm not going to tell you the real answer. Because not that I don't remember it, I just don't feel like telling. This is a trig identity. So this is a very simple formula called the range equation. dx, if you launch something off the ground and it lands on the ground at the same height, dx is the range. V naught squared over g sine 2 theta. And what's the maximum value? No, what theta gives you the maximum value? Well, the maximum value of a sine is 1. That's when you take the sine of 90. So 2 theta equals 90. What's theta? I was right, 45 degrees. Good job, me. I'm a scholar. I did it. That's the range equation. This is the derivation of the range equation. It was a lot of algebra, but not that much. It was doable. Okay, now for a harder problem. We're going to do the same one as yesterday, but the object's not going to land at the same height. Let me look at my notes. Did I do this right? I think that's the right formula. Okay. So let me write down what I was talking about. I forgot to ask you guys, but it doesn't matter. Okay, so the problem from yesterday v theta it's v naught, v x naught, v y naught. So this is the problem from yesterday. You guys see it? Yeah. The numbers I gave yesterday was that the initial speed of this object is 35 meters per second and the angle 72 degrees. So this will just be v naught sine theta, which was 33.3 meters per second. This will be v naught cosine theta, which will be 10.8 meters per second. Okay, so now, same problem. I'm finding dx. But the object is not launched off the ground to land on the ground at the same height. Let's say in this case, it's launched off the ground and goes off a cliff and lands at the bottom of the cliff. And the cliff has a height of 54 meters. That's my problem. Does that look good? Yeah? So same question, find dx. But now I changed the problem. It doesn't land on the ground, it lands at the bottom of the cliff. I shot this ball or whatever off a cliff. So I threw it real far. It will go farther than last time, but how much farther? How do we change the problem? Tell me what's different about this problem compared to yesterday. Yeah, good job. Wow, thanks for telling me. Some things are the same. AX is still 0. AY is still negative 9.8 meter per second squared. Hopefully you just told me that this is dy. dy is 54 meters. But if I say my AY is negative, dy is negative. You could make them both positive if you wanted to, but you're going to be really confused in this next step. Be x naught equals 10.8 meters per second. Vy naught equals 33.3 meters per second. It's really important that you be consistent with dy, ay, and vy naught. You gotta be consistent. What am I talking about? What does that mean? What has to be consistent? Consistent means you gotta be decisive with your sign. Either up is positive or down is positive. You can't have both. So that's all this rule. Either up is positive or down is positive. This displacement is downward, so it's negative. This acceleration is also downward, so it's also negative. The initial velocity in the y direction is upward. So this has to be positive. Negative, negative, positive. If you had switched one of them, you're going to get the wrong answer. Side note, if you switch all three, you'll get the right answer. If you switch all three, you're basically saying that upward is the negative direction. And you're finding a time which doesn't have direction, so you're going to be fine. But to keep it simple for yourself, just make upward positive in most problems. Now we gotta solve. dy equals vy naught t plus 1/2 a y t squared. Good, there's a squared. Okay, I'll substitute for you guys, that's a mess I am. 54, negative 54 meters equals 33, no, I'm gonna make this 2 lines. 3, let me write it bigger. Eraser, help. 33.3 meters per second t plus 1/2 negative 9.8 meters per second squared t squared. Now you gotta solve this, but you can't use the trick we did before. You can't divide the whole thing by t, because then the left side will be 54 meters over t, which is really not helpful. So use your quadratic solvers, either quadratic equation or your graphing calculator. Solve for t. Something weird. You're going to get 2 answers. Probably one negative, one positive. What do we do? Why do we have 2 answers? And then what do we do? Look at the picture. We're trying to find the time, t, when the ball is at this height here, negative 54 meters. So when we solve this formula, we're finding t when d is negative 54. Writing letters. When d is negative 54 meters, what's t? That's what this equation is finding. Why will this give us two answers? And then what do we do with those two answers? Tell me right now. Hopefully you realize we ignore the negative answer. Because basically, what you're finding is when this parabola hits this level, of course right here, but there's another time the parabola hits that level, in the negative time. Before it was launched, if it kept on this path, it would go backward like this and hit dy equals negative 54 meters at some negative time. But that didn't really happen, so we gotta ignore the negative time. I believe the time comes out to 8.1 seconds. And that makes sense. When it landed on the same height, we got a time of 6.8 seconds. But if it still falls even further than that in this new problem, our time is 8.1 seconds. That's more than 6.8. It does make sense it takes longer to reach the ground. So now we got time. It's pretty straightforward to just find dx, just like before. It's vx naught t. 10.8 times 8.1 is 88 meters. That was great. There's lots of other things that could be solved too. You could also find vx, vy, and then even v. Vx naught would be, vx would be vx naught plus at. Vy would be vy naught plus at. So plug in t, plug in the a's. Obviously use ax on this side and ay on this side. I made that mistake on purpose to trick you guys, to check if you were paying attention. Everything x's, everything y's. If you do the math, vx comes out to something. Oh, vx is 10.8 meters per second. How do we know it has to be that? Tell me. Vy comes out to be negative 46.2 meters per second. And if you want to find v, the total v, this is vector composition. We know basically what is v. Don't give it to mathematically in words. What does v represent? Good job, guys. V is the final speed right here. Obviously, when the ball hits the ground, it'll probably stop moving and have speed 0. But v, we can't talk about when it hits the ground, because when it hits the ground, ay is no longer negative 9.8 meters per second squared. So right before it hits the ground, it has some speed v, which is two components, vx and vy. So v is the final velocity. And it would be the square root vx squared plus vy squared. It comes out to be 47.4 meters per second. It's at this angle too. You could find angle theta. Angle theta would be the inverse tangent of negative 46.2 over 10.8. So it would be Beep, beep, boop, boop, boop. I'll tell you in class if you want. Thanks for watching my great lesson. See you guys tomorrow later.